Venus, our nearest neighbour, appears as an incredibly bright star in the night sky. It's so bright, it's the second brightest thing in the night sky. It's so bright that the ancient Romans decided to name it after their goddess of love and beauty, Venus. But this planet is far from the beautiful place that the Romans saw it as. First, let's begin with Venus's orbit. Venus orbits at an average distance of 108 million kilometers from the Sun. It has the most circular orbit of all the planets, and it takes 224.7 days to complete one orbit, which is about 8 months on Earth. Venus has the slowest rotation period of any planet in the solar system. It takes 243 days to complete one rotation, and this means that Venus' day is longer than its year. Not only that, but Venus does not spin the normal way like all the other planets in the solar system. It spins retrograde. That means it spins clockwise rather than anti-clockwise like all the other planets do, besides Uranus. Now, the reason I have removed clouds in this animation on Space Engine is because if I had clouds on, then the clouds would rotate much faster than the planet actually is. So with clouds off, you can see the true speed at which the planet rotates. This retrograde rotation is a great mystery. When we think of when the planets form, they form around the Sun as a disk. They go around the Sun in that same anti-clockwise direction because that's the way that the gas cloud was spinning at the time of the Sun's birth. And even though the rotation shouldn't be related to the orbit time, the planets should still all spin in the same direction as the spin of the initial dust cloud that formed the solar system. And so quite how Venus has somehow gone the other direction is a great mystery. Obviously something very violent must have happened deep in its past. A massive body perhaps collided with it and gave it just enough kick to go in the other direction. Venus is around about the same size as Earth. It's about 12,103 kilometers. It's only 600 kilometers smaller than Earth. As you can see on these animations in Space Engine, the clouds are completely blanketing the planet. You cannot see what is underneath. So even up until the 1950s, astronomers speculated that it could be like a jungle type world, a steamy jungle infested planet with oceans even. And so much so that when the A.e.r.o probes were being prepared to go to Venus in the 60s and 70s, they prepared for a splash landing. Of course, first impressions can be deceiving, and in the case of Venus, that was definitely the case. Its temperature at the surface is 464 degrees Celsius on average. That is hot enough to melt lead, and unlike Mercury that we explored in the last video, the night side of Venus has roughly the same temperature. It doesn't lose anything off to space. It doesn't lose anything off to space because its atmosphere is incredibly thick. It is 92 times the atmospheric pressure here on Earth. That is more than enough to crush your car in just a couple of seconds. Pressure is essentially a measure of the force that a gas applies onto the surface of a planet or anything on the surface per square meter, and it's measured in pascals. On Earth it's about 10,000 pascals. On Venus it's about 900,000 pascals. So it is absolutely crushing. So Venus is absolutely not a place where anything can live. Its atmosphere is made up of 96% of carbon dioxide and trace amounts of argon and nitrogen and stuff like that. But its clouds are made up of sulfuric acid that has likely come from volcanoes erupting on its surface, which we will get onto soon. In the atmosphere we've also found water, and it's significant enough that we think billions of years ago in the past that Venus was a bit like Earth. It did have oceans, it had rivers, lakes, everything. It's impossible to know if life could have existed on Venus back then, because obviously we're never ever going to go back to that time. And so how did Venus end up as the hell world which we see today? The answer was revealed by a combination of Pioneer 12 from 1978 to 1992 and Magellan from 1990 to 1994. And removing the atmosphere here on Space Engine, we can see the surface of Venus in all its details. What Magellan and Pioneer 12 found is that there are lava flows all over Venus that have come from volcanoes on the surface. So this gives us a clue on how Venus could have had its atmosphere, because at least on Earth, volcanoes emit huge amounts of sulfur dioxide, carbon dioxide, lots of toxic gases, but more importantly, greenhouse gases. Carbon dioxide is a strong greenhouse gas, and essentially greenhouse gases create the greenhouse effect, which is very synonymous with climate change here on Earth. So what happens on Earth is that the atmosphere is transparent to visible light, which is obvious because we can see the sun. But as the sun's rays come through the atmosphere and hit the ground absorbs the visible light and radiates it out again as heat energy, so infrared radiation. Now greenhouse gases, like carbon dioxide, they absorb the infrared radiation. They absorb that heat. And so they essentially trap it in the atmosphere. And so the planet's surface, the planet's atmosphere, it heats up. Now, Venus is an extreme case of the greenhouse effect. It's called a runaway greenhouse effect. And so with all the carbon dioxide and all the gases being released by the volcanoes, it created a thick atmosphere. So when the sun's rays came in, they didn't come out, and they are still trapped within Venus's atmosphere. Then the planet is basically a hell world. Now there are about 50,000 volcanoes on Venus, and that is far more volcanoes than we have on Earth. And so that gives you an idea of the scale at which these gases were being produced. And so that explains the enormously thick and toxic atmosphere we see today. Now, whether these volcanoes are still erupting or not is an active area of research, and we simply do not know at this current moment in time. At this moment, it's pretty much impossible to know if volcanoes are erupting on Venus because of its incredibly thick atmosphere. We can't look through it with ease. The only way Magellan was able to peer through the atmosphere was with radar, and so we don't have an incredible map of Venus like we do with the other planets. But what we do know, having studied Venus over the years, is we know that Venus does not have a magnetic field. Now this is exceptionally interesting, and it's unusual. For a planet the size of Venus, you would expect a magnetic field around it, but it does not. A magnetic field is essentially a protective shell, an invisible protective shell around a planet. It deflects the solar wind away and around the planet, and it's the thing that forms the aurora on Earth. But on Venus we see no such magnetic field. This is exceptionally interesting because without a magnetic field, the solar wind from the sun should be able to blast Venus's atmosphere off and away into space. Now, the fact that that hasn't happened over billions and billions of years gives us a tiny little tantalizing clue that the volcanoes on Venus could still be active and erupting, maybe even as we speak. It would definitely make sense for Venus to have current volcanic activity because it's pretty much the same size as Earth. It would have retained its internal heat from its formation, as the Earth has done today, and so volcanoes may very well be still erupting. Now in 2020, scientists at Cardiff University discovered that there was a very small trace amount of a gas called phosphine. Now phosphine on Earth is only created by biological processes. And you might remember that this caused a great deal of excitement that there could be life in the atmosphere of Venus. Now, high in the atmosphere, the pressure will be lower than on the surface, so potentially you could have aerial bacteria floating around the atmosphere of Venus. But however, since then those measurements have been questioned. Further measurements showing that the amount of phosphine is much, much, much lower, perhaps even zero. Now, our evil twin has been visited successfully by 27 different spacecraft. It is the most visited object besides the moon, and most of those came from the Russian Venera spacecrafts in the 60s, 70s and 80s. But ever since NASA's Magellan in the 1990s, Venus exploration has been a bit patchy. Venus Express went there in 2005, Akatsuki arrived at Venus in 2015. There's not been much Venus exploration since Magellan in the 1990s. However, there are some missions that have been approved recently that are going to be on the way to Venus at the end of this decade. NASA in 2022 chose 2 new Venus missions, one called Veritas and one called Da Vinci Plus. Now, Da Vinci Plus is a balloon that will go through Venus's atmosphere and land on the surface, and it will study the Venusian atmosphere in situ. Now, Veritas is a Venus orbiter. Its job is going to be to map the surface of Venus in more detail than we have ever seen before. Magellan did a good job, but we can do even better with the technology we have now. And also Europe is planning a mission called Envision, also to map the surface of Venus in high resolution. All 3 spacecraft are expected to arrive at Venus at the turn of the next decade, and they will be launching in 2029 and 2031. It's certainly an exciting time for new Venus exploration, and we are about to see it unfold before our very eyes. What mysteries will we discover about the hellish second planet from the Sun? Thank you everyone so much for watching. I hope you all enjoyed, and I hope to see you next time for our home planet. Goodbye everyone. First, let's begin with Venus's orbit. Venus orbits 108... What the f***? That means it spins clockwise rather than anti-clockwise.